Hi everyone, and welcome to Maths Revision with Jov. Today we'll be going through a problem that involves some area of circles and squares, it looks like. And it reads, a square with sides of length x millimetres is inside a circle. Each vertex of the square is on the circumference of the circle. The area of the circle is 64 millimetres squared. Find x. To approach a problem like this, the first thing I always try to do is to draw out the shape that it's asking me for. So it says a square is inside a circle. So I want to draw a circle and a square in which each vertex of the square is on the circumference of the circle. So that'll look something like this. If you can see that all right, I hope. And it says that the sides of the square are length x millimetres, so we can forget the millimetres for now because we know we're just going to be working in millimetres the whole time. So you can say that is x. The question also tells us that the area of the circle is 64 millimetres, and we know what the area of the circle is. We can say that pi times r squared, where r is the radius of the circle, is equal to 64. But hey, what's our r? We haven't put an r in yet. So let's go ahead and do that. We can draw a centre there and say this little length here is r. The two things we want to do, one of them is we want to find r in terms of our area, and I think we can do that quite easily. And then the other thing we want to do is find x in terms of r, or r in terms of x if you like, because we're solving for x. So we can go ahead and solve for r first. I think that's probably the easiest way to achieve our goal. So r squared is 64 divided by pi, because I'm dividing on both sides by pi. And then r is 64 over pi, all square rooted, just like that. Now we need to find an expression for x in terms of r. And we can go ahead and do that by looking at this diagram carefully. We know that if we draw a line across the middle, this is just going to be the length of the side because I've just moved the line down a bit. So that's x. We can also draw a line down from the middle of the square and say that is x over 2 because we're just taking half of the length of the square, which means that this little bit here must also be x over 2. Now we can notice that we have a right angle here, and this can also be called x over 2, just to see where we're going with this. And then we can write a simple equation using the Pythagorean theorem. We've got x over 2 squared, which is this side, plus x over 2 squared again, because you've got this side as well, and that's equal to r squared. We can simplify this a bit. We've got x squared over 4, because I've squared the x term and I've squared the 2 here. And we've got another one of those nicely here, and that's r squared. I'm going to move it over here a bit. We can just add these two fractions. We've got a quarter of x squared plus another quarter of x squared. So that gives us a half of x squared equals r squared. Finally, we've got our two equations here, which is enough to solve for x now. I've squared both sides of this one again because it's actually simpler, as the r squared turns up in this equation on the left here. So it makes it really nice for a substitution. If we just combine these two equations, we get that x squared divided by 2 is equal to r squared, but r squared is equal to this thing over here, this 64 over pi. We can solve this equation really nicely. It's a really nice little solution. We've got x squared equals, so we want to multiply both sides by 2 to get rid of this fraction. So 2 times 64 is 128. Pen almost ran out there. And then we're still dividing by pi, which now leaves us with the fact that x must be 128 divided by pi, all square rooted, which I think comes out at about 6.38 millimeters. And there we go, I hope that helps.